Welcome to Maths with Paru. In this video, I shall be discussing a question from October 2021 Pure Mathematics 2 examination paper, and it's question 7, which is based on geometric sequences. Here we go. Let's start with the first part of the question. Here the question says, we have a geometric sequence and the first term of the geometric sequence is 4 and the common ratio is 6. Given that the nth term is greater than 10 to the power 100, find the minimum possible value of n. Now, let's remind ourselves, in a geometric sequence, the first term is given here. So the nth term of a geometric series would be Tn is equal to ar to the power n minus 1. That's the nth term of a geometric series. Now here we're given that a is equal to 4 and r is equal to 6. So we have a is equal to 4 and we have r is equal to 6. Right. Now let's see how we're going to show that we have been told already that the nth term is greater than 10 to the power 100. So here we go. We have Tn is greater than 10 to the power 100. A is equal to 4, r is equal to 6, Tn is ar to the power n minus 1, which is 4 into 6 to the power n minus 1. So we end up with 4 times 6 to the power n minus 1 is greater than 10 to the power 100. And then I'm going to take the log of both sides. So that will be log of 4 times 6 to the power n minus 1 using your laws of logarithm. Log of a, b is equal to log of a plus log of b. So we have log of 4 plus log of 6 to the power n minus 1 is greater than log of 10 to the power 100. Now we have log of 6 to the power n minus 1 can be written as n minus 1 log of 6. And I'm going to take the log of 4 to the other side. So we end up with n minus 1 into log of 6 is greater than 100 log of 10 minus log of 4. Then I'm going to divide both sides by log of 6. And I know that log of 10, base 10 is just 1. So I end up with just 100 minus log of 4 over log of 6. If I put it in my calculator and evaluate it, I end up with 127 plus 1. Because 100 minus log of 4 over log of 6 is 127. Then I have to bring the minus 1 to the other side and make it plus 1. So I end up with n is greater than 128.7. Now we know we're talking about the nth term, so it has to be an integer. So the only value that it could be just above 128.7 would be 129. So that is the minimum possible value. So the answer for part 7.1 is n is equal to 129. Now let's move on to the next part of this question. In part 2, they say that there's a different geometric sequence. And in that geometric sequence, they have said that the second term, T2, is equal to minus 6. And we know that the second term for any geometric sequence is simply AR. And we've also been told that the sum to infinity equal to 25. Now the formula for sum to infinity is just a over 1 minus r. That would be the formula for the sum to infinity, just to refresh your memory. So here we're going to now use this information, right? So here we go. We have second term is AR, which is minus 6. Sum to infinity is a over 1 minus r, which is 25. We have two equations, and I'm going to divide one equation by the other, so I can get rid of a. So r divided by 1 over 1 minus r is a over 1 minus r is going to be r into 1 minus r, and that's minus 6 over 25. If I multiply it out, I end up with r minus r squared is equal to minus 6 over 25. I bring the 25 across, I cross multiply, and if I do that, I end up with 25r minus 25r squared is equal to minus 6. And then I rearrange it so that I end up with the equation that they want us to show. So here I have shown this equation, 25r squared minus 25r minus 6 equals 0. So that's the answer to question 7, part 2. Now let's move on to the next part of the question. So here, the next part of the question will be to write down the solution for this. Now, we can go to our calculator and put it into the formula in the calculator. And if we do that, we'll simply end up with the answer to the solutions for this, which is r is equal to 1.2 and r is equal to 0.2. Let's move on to the next part of the question, which says, state the value of r, giving your reason for the answer. So now we have two options. We have r is equal to 1.2, and we also have r is equal to minus 0.2. Now keep in mind that we were given an s infinity. We only have a sum to infinity if the common ratio, which is r, is less than 1. So now it's going to be easy for us to actually make the decision about which r we should consider. Since sum of infinity exists, so that means that the absolute value of r has to be less than 1. Therefore, we have only one solution, which is r is equal to minus 0.2. So that answers our part B and part C. Next, we go to part D, and they say find the sum of the first 4 terms of the series. Now, we know that we're given term 1, which is a, and that's 4, and then we have term 2, which is ar minus 6. So we have from our right. So now what we have is we have r is equal to minus 0.2, and we're going to now substitute the value in T2. So since ar is equal to minus 6, a into minus 0.2 is equal to minus 6, and we find that a is 30. If a is 30 and if r is equal to minus 2 and n is equal to 4, we can use the equation we have for sum of 4 terms. S4 is a into r to the power 4 minus 1 over r minus 1. A is 30 into minus 0.2 to the power 4 minus 1 over minus 0.2 minus 1. When we evaluate that, we end up with this answer, 24.96. So that answers question 7, part D. I hope you understood my explanation. Thank you for watching. Until my next video, goodbye for now.